Right, so we're solving radical equations. We're using Pemdas to help us as a tool. Now, let's be clear, Pemdas is not some sort of magical phrase that just automatically does things. It's a tool that helps us keep track of our operations. Now, you can do operations in any order, but this is the order that will help you isolate the variable every time. And so sometimes there's maybe a faster order or a different order that's useful, but in general, if we use this order, we will isolate the variable without a problem. And so sometimes it's useful to like divide everything first or multiply everything first. But in general, if you use this order, it will help us get to the answer the fastest. And we're adding things in this step, right? So radicals are exponents, and exponents are radicals, right? Radicals are just fractional exponents. You've done a whole lot of equation solving. And so some of these things, I'm going to be like, well, you saw this in 8th grade. There is a slight expectation that you remember it, but also I completely understand that not everyone learns everything the first time. And every year I run into students who didn't learn this in 8th grade. They sat through class for it in 8th grade, but it didn't click. And so I get that. I get that. If that's you and you still, even after Algebra 1 and all those things, don't know how to solve an equation, you should come to office hours so we can walk through it more clearly. And that's also why I kind of review this in depth every time instead of just being like, here's what we're doing, go ahead. Okay, so we're starting from the bottom and going up on Pemdas because that helps us isolate variables. Going the other way simplifies equations. In other words, without a variable. So it's just like if we only have numbers, going down simplifies. At the exponent step, our inverses are going to look like this. So before we had x to the fourth, the inverse was like the fourth root, right? We take the fourth root of both sides, that will get rid of the power of 4 here. Now we're going to have stuff like the square root of x, and we're not really going to go higher than the cube root, but you could. The square root of x, and then the inverse is going to be squaring. Or if we have the cube root of x, the inverse would be to cube stuff. Remember, this has an invisible 2 here, which makes it the square root. And that's really the only new thing. It's not super new because these are basically the same. But we're just going to be solving equations. For some of you, this is going to click really quickly because this is the kind of math that feels good to you. So we'll see. I've noticed that too. Solving equations, which means we're going to have some equations to solve. And let me know if I'm going. My mouse is just cold. It's weird. I'm going too fast. Okay, so first example, we're going to do 2 examples. I'm going to be like, all right, here's a problem. Do it on your own, and then we'll check our answers together. Example 1, 2 times the square root of x plus 1 equals 4. When we're reading these, we need to be careful with a couple things. This is 2 times the square root. This 2 is not the tiny 2 that would go here telling us that it's a square root. And this one is inside the square root. It's not outside the square root. And so when we look at PEMDAS, and I'm not going to write this down every time, we have addition, we have some multiplication, and then we have a radical, so we have the exponent. Usually we're just like, all right, start at the bottom and work our way up. But if I add 1 or subtract 1, right, because it's the inverse, if I subtract 1 to both sides here, I'm not actually simplifying anything because this is inside the radical. We're going to start doing our inverses outside, and then we're going to work our way in. If you go to page like 256 in your textbook, there's some steps that you could read. I'm not going to use those steps. We're just going to solve. But in general, we're going to do the inverses outside first and then the stuff inside. This is because technically this radical here is a grouping symbol, like parentheses kind of. It's an exponent though. So we're going to do outside then inside. So instead of subtracting first, I'm going to do the inverse of multiplication first and divide on both sides. So the square root of x plus 1 is 2. Okay, so now we're at our step where we need to get rid of the radical. When we square stuff, we want the radical to be the only thing on one side. Otherwise, we're going to have to do some kind of weird distribution that won't actually simplify things. So radical is the only thing over here. So we're going to do the square root of x plus 1 squared is the same as 2 squared. We're square both sides. We're doing the same operation on both sides, so it's not changing any values. They're still equal. If we just squared this one side, that would change the problem, but squaring both sides means it's still equivalent. And then this just cancels out, and we're left with x plus 1 is 4. If this is confusing to you, remember that like the square root of 9 squared is the same as, I should have written this a little bit lower because x is going to equal 3. I don't want to get this in the way. Is the same as 3 squared, right? The square root of 9 is 3 squared, which is 9. And so the inside part here is what we get back out on the other side. So even if we have a variable in here, inside just stays the same when we have a square root and a square. They cancel out. Okay, and so then we would subtract 1, and we'd get x equals 3 as our answer. If we have any questions on that, we can always send me a private chat message or put it in the general chat. Yep. All right. So we get x equals 3. We could plug this back into here, and it should be equal, right? If I do the square root of 4 is 2, 2 times 2 is 4. So we can always check our answer by plugging this back in and then simplifying. Okay. For our second example, we're going to do a cube root. None of the homework has a cube root in it. But I want you to see one anyway, just in case. Minus 1 equals 2. Okay. All right, notice this 3 here means this is a cube root. It's not 3 times a square root. It's a tiny little 3. When we type out our math equations, this is more clear. My handwriting doesn't always help, but I don't want you to be confused. We are not multiplying by 3 like we were multiplying by 2 up here. So this is the cube root. So with Pemdas, going inverses, we have two subtraction things. One's inside the radical, one's outside. And if that's not clear, I'm sorry. It ends right here. And so the -1 is outside, the -9 is inside. We have multiplication, and we have a cube root. All right, so we're going to work our way outside to inside. So we're going to get rid of this -1 first. I can't combine the -9 and the -1 because the radical goes to here. And so I'm going to add 1 on both sides. All this stays the same. That equals 3. Okay, so that was one of my subtraction things. Now, since I have the radical by itself, I can do this inverse, which would be to cube both sides. So generally, I'm not going to rewrite each line with the parentheses and then do the cube. You could just add the 3 to both of these. So we have the cube root cubed, that cancels. And then 3 cubed is going to be 27. And now at this point, this is just a linear equation like you have seen in Algebra 1 in 8th grade. And it's only going to be a couple steps, right? We're just going to either add or subtract and multiply or divide. Once we've gotten rid of the radical by doing the cube or square, depending on the problem, we only have a couple steps left. Okay, so I am going to start back at the bottom of my PEMDAS and work my way up. So I have some subtraction to get rid of by doing the inverse. And so we get 2x equals 36. And then we have multiplication to get rid of by dividing. And so x is 18. And we could, of course, plug this back in and simplify, and we would get 2. Feeling good? Okay, so here's what we're going to do. We're going to do a bunch of problems from the homework worksheet. Only some of them are due as homework, but we're going to work on a bunch of them. Okay, and if you move faster than I do, in other words, I'm going to give you like 2 minutes to work on a problem. If you're done really quickly, just go on and do another problem. So the PDF, you can go into your homework assignments and find it, but it's also in chat in just a minute. This page. There you go. If you open that, those are some of the problems we're going to do. We won't do all of them. Start with number 3. So number 3 is the square root of v minus 4 equals 3. All right, so I'm going to give you about 2 or 3 minutes to finish that problem on your own, and then we'll check our answers. Okay, and if you have any questions, send me a message and we'll talk. We can chat individually, or I can talk about the problem corporately, which just means together with everyone. Okay, so 2 to 3 minutes. Puts us at like 38, 39. Yes, Brooklyn. Yeah, every day this week from 2 to 3. I already put the link into the office hours channel on the Teams page for today. And I'll put tomorrow's in tomorrow, probably in the morning. And if you need to meet, earlier, I could probably do that, actually. I can't meet after 3 though. Luke, kind of, yes. Like if you are ahead of me, if you did number 3 already, like do the ones that we're working on together first. But if you finished it, we're go on to the next problem. So I want you to get as much practice as possible. Okay, so here's what I'm going to do. I'm going to put the answer into, what order do I want to do this in? I'm going to work it out, and then I'll put the answer into chat, and I want you to emote your response to the message with like a thumbs up or an angry face, depending on how you did. All right, we've done this before. So I'm going to square both sides. So v minus 4 is 9, and so then we would add 4. And so v is going to be 13. So if you got v equals 13, give me like a thumbs up or a positive emote. And if you did not get that, then give me an angry one. If you mouse over the timestamp, it will more obviously, or it will pull up the emoticons. Interestingly, I can respond to my own message with an emote, which I think is kind of silly. Okay. The more people that respond, this isn't like a gauge to get like everyone who just got it right. I also need to know if people didn't get it right so that I can address things. But if you're not comfortable doing that, just send me a message. Okay. Just send me a message. All right, so let's go on to the next one. Let's do number 2. I'm going to modify number 2 from the worksheet. So I'm going to add in a half. It's going to give you the same answer. So on that worksheet, all the answers are on the back. I don't care that you know the answers. I need you to show me that you can do the steps and do the work, right? I need to move my paper. So answers are in the back. That's fine. So for this, there's 2 ways to think about this. This is 1/2 times the square root, or because we have a half, we're dividing. So the way that I would do this is I would just multiply both sides by 2 to get rid of the half. I'm not going to work out the whole thing. I'm just showing you this first step. So multiplying both sides by 2, these cancel out. You can also, because it's multiplication, divide both sides by a half and you'll get the same thing. You should get, when you divide 5 by a half, you should get 10, which is a bit counterintuitive and not how I would do it, but I had a student ask me about that, so you could do it that way. All right. So workout number 2, I'll give you about 2 to 3 minutes and we'll do the same thing. And like I said, if you're finishing faster than I'm going through the problems, just work through all of them, as many as you can. The homework is not all of them, but I want you to see as many as you can get through. All right, so once we've gotten rid of the 1/2 here, we have the square root of m, I'm not muted, that's good, over 10 is 10. And so the thing we do to get rid of the radical is we square both sides. You'll notice I'm not writing Pemdas out. You can, please do, right? It's just I don't need to do it every time. And so, yeah. Once we're to this divide by 10, then I multiply everything by 10 and I get m equals 1,000. So m equals 1,000. If you could emote that, if that's what you got or did not get, and let me know if we're having any issues, any questions on what to do. Okay. So now we're going to, oh, I muted myself. That's silly. I want to do number 6 next. All right, so we're going to do number 6. Number 6 I want to do because it switches which side the radical's on, which actually doesn't change the problem at all. So we have, 5 equals square root of x plus 3. So I'll give you a couple minutes to work on that, and then we'll talk about it. It doesn't actually change what we're doing with the problem. We still need to square both sides. This is equivalent to if we just switched the square root and the 5. So x plus 3 equals 5. You could write those either way, right? We have an equal sign, so we can flip what's on each side of the equal sign. Okay? So you can work out either of these problems. They're the same thing. I would do this one, right? Because there's other problems that look like this. So just square both sides of this and work down. But you could also switch them if that feels more natural to you or easier. It does. It's whatever. Okay? So about 2 minutes to work on that one. Jets are a football team that I hate. I don't hate them. They're probably lovely individuals. Maybe not. Anyway, we're going to square both sides, right? Get rid of the square root by squaring both sides. Every single one of these problems is going to ask us to square both sides. And so square both sides. We get 25 equals x plus 3. Subtract the 3. So we get 22 equals x. Okay. 22 equals x. What do I want to do next? Let's do number 9 next. I feel like some of us have already moved on past that one, but that's fine. Okay, so it doesn't matter which side of the equal sign we have stuff on. It's the same on both sides. Equals means equivalent either way. Which one did I say? Number 9. 9 is negative 8 plus, sorry, here. The square root 5a minus 5 equals negative 3. Okay, so we have some stuff outside. We're going to have to add, and then we would take the square root. Don't take the square root first. I mean, don't square both sides first and say you get 64 and 9, right? That is not going to help you. It might feel right because we have the square root, and squaring both sides would get rid of that. But if we have this minus 8 over here, we would need to distribute the multiplication, and so we would still be left with the square root. And so it doesn't actually help us simplify anything. So instead, add first, and then square both sides. All right, so work on number 9. Remember, my expectation right here is that you're working on these on your own, and then we're checking our answers, or really we're checking our work, possibly, and then messaging me if we're having any confusion or issues. let's work through this. So there's actually quite a few steps to this specific problem because we have about as many as one of the examples though. Addition here, addition for this, we have to square and divide. Oh, what is with the airplanes today? So we add 8, the square root of 5a minus 5 is going to equal 5. When doing these, it's not that your answer will always be positive. Sometimes you'll get a negative answer for the variable, but the square root part should always equal a positive number because we're not dealing with imaginaries. Hopefully that makes sense because before I go on to another problem, or before I finish, right, if we have the square root of x equals -3, our initial idea here is, oh, we just square both sides, right? Square both sides. We get x is 9 because -3 times -3 gives us 9. So we're like, oh, right. But if I plug this back in here, the square root of 9 is not -3. The square root of 9 is 3. It's only when we're doing like x squared equals something that we get positive or negative. When we're doing square roots, it has to equal a positive number. So this does not work. Really, there's an imaginary number here that works, but sorry. You won't be given a problem where it equals a negative. In other words, we need to add first to get this to be a positive number. Okay, so then we square both sides. I should probably make that a different color. Show that it's a different step. Just markered my finger. And so we get 5a minus 5 equals 25. Add 5 to both sides. 5a equals 30. That means a is 6, and we are finished. Okay. One more. You'll notice the second page of the document and about half the homework problems that I assigned look like this problem. And I sure hope I didn't randomly make this a homework problem. That would have been silly. The square root of x over 10 equals the square root of 3x minus 58. Square roots on both sides. Square roots on both sides. What do we do? Well, we do the thing we've been doing. To get rid of the square root, we just square both things. And so then x over 10 is equal to 3x minus 58. The squares cancel both square roots, and then we're left with a problem that requires some solving, some more normal solving. There's that mathematical way to think of it as, okay, we square both sides, the step-by-step process more. There's also the logical way of just, if this has a square root and this has a square root and they're equal to each other, that means the insides have to be the same, whatever they are. This has to be the same as, x over 10 has to be the same as 3x minus 58. Because if these are equal and we're square rooting both of them, then the insides also need to be the same. Okay. I'm actually just going to finish solving this problem because if we're using Pemdas exclusively, we might think, oh, to combine these like terms, we need to add and subtract first, but that is not what I would do. And this is what I was saying at the beginning, is sometimes it's easier to not do the Pemdas order because we have this divide by 10 here. Let's just not deal with the fractions. I can actually do the operations in any order I want. I just need to make sure I'm distributing fully or fully doing the exponent or any of that kind of stuff. And so I'm just going to multiply by 10. All the numbers by 10, it'll cancel this fraction, and so x is 30x minus 580. Same, technically the same equation. We've just gotten rid of the fraction. And you could do that with any fraction. 10 is just easy because you just add zeros to the numbers. So then I'll subtract this over negative 29x equals negative 580. X has to be 20. Okay. So we have about 12 minutes left. Now's a good chance to send me questions in chat on this or work on the homework. Or you can ask me about your grade, right? I'm not going to go through any other problems, I don't think, unless we have specific ones that we want me to do, which I can and will do. But work on the worksheet and let me know if you have any questions. It's possible in the next 10 minutes you could finish all the homework. Yes, Brooklyn, I have not put those in. I have not done that, and I need to, and I'm sorry. Yes. Yeah, a bunch of people did. It's not just you. It's not just you. So yes, I do need to do that. I suppose I could do that right now. Most of you can ignore what I'm going to do right now. This is an interesting question. You're not going to have any problems like this on the quiz or any test. But if we have a square root equal a cube root, I'm just going to put a number in here. 4. Really, unless there's a variable in, actually, there needs to be a variable in this for it to work. Really, if there's no variable, if it's just the square root of x equals the cube root of something, just square both sides, and then you get x equals whatever this number is. Right, you'd use a calculator and get a decimal. Yeah. If there's a variable on both sides, you can't just square it and then simplify this. That's not going to work. You need to raise it to a power that has both a 2 and a 3 in it. So you'd raise it to the 6th. Which means you get x cubed equals 4 minus x squared. And then you have to solve this cubic function, which we have not talked about how to do. And we will talk about how to do that after Christmas, but we won't have problems that look like this. So it is possible. But we're probably never going to see a problem like that, actually. I don't like being that teacher who says it's not possible. No, it's totally possible. Math is the kind of thing where almost anything you can think of is possible, or attemptable. Maybe is a better word. Not everything's possible. Like I don't want to be that teacher that I had in like 2nd grade when I asked, "What if you divided 4 by 5?" Like you can divide. Because teachers in elementary school are like, you can only divide big numbers by smaller numbers, right? 20 by 4. That's not true, right? You could have 4/5. And so I don't want anyone to ever have that experience because it's stupid to be told that something is possible and you be sitting there being like, no, but I'm pretty sure. Pretty sure you're not telling me the truth. So, yeah. This is a solvable problem, by the way. You get a cubic function, and that might be factorable. It might not be factorable. We'd probably use a graphing calculator to figure it out. But yeah, there are no problems like this on the test. No problems like this year, next year. We're not going to do stuff like that. We'll do stuff like this, but not with the roots. Okay. I think that's it. Oh, we got 4 minutes. So, if you got any questions? We got questions. I'll be here. Oh, I was looking up Brooklyn's. I was looking up the retakes for that test. We are in 4th period, so it would be this one. I think that's it. Okay, so